A titration is used to determine the amount or the concentration of an acid or a base. You have an acid or a base that's going to be in the burette, and that's going to be of known pH. And then in your flask, you're going to have a known pH. There's going to be new units in titration, which is a millimole, and that's mmol. So molarity is millimole per milliliter. So it's the same as moles per liter, we just put milli in front of both of them, since we'll be dealing with smaller units. The equivalence point is the point in the titration where an amount of acid or base has been added to exactly react with all the acid originally present. So you have equal amounts of acid and base in the flask. So we're going to be looking at a couple of different problems in a titration. And it says that we're starting with 50 milliliters of a 0.2 molar nitric acid solution. Nitric acid is a strong acid, so we're going to need to write our dissociation equation. And if I have 0.2 nitric acid, I also have 0.2 hydrogen and 0.2 nitrate. The only thing that matters is our hydrogen, so we can find our pH by taking the negative log of 0.2, which gives us 0.699. So that's our starting pH. Okay, now we're going to add some NaOH to the flask. And we still have our 50 milliliters of a 0.2 molar nitric acid solution. We're going to need to write our equation out. So nitric acid is going to react with sodium hydroxide to produce sodium nitrate and water. You're going to ignore water. And remember that sodium nitrate is neutral because it's going to be made of a strong acid and a strong base. Okay, first step was we need to figure out how many millimoles of each substance we're starting with, because we're going to need to do stoichiometry. So my 0.2 times 50 milliliters gives me 10 millimoles of nitric acid. And I have 1 millimole of sodium hydroxide by multiplying our 10 times 0.1. And we don't have any sodium nitrate. We're going to react them. So -1, plus 1. So we have 9 millimoles, 0, and 1 millimole. So you've got to look and see what you're left with. We're going to need molarity, so we need to divide by total volume. So we have 10 plus 50 gives us 60 milliliters. So we have 0.15 molarity. And 0.0167 molarity. So we have a strong acid and a neutral salt. The neutral salt doesn't matter. So really we're just left with a strong acid, and so we can take the negative log of 0.15 to give us a pH of 0.824. Now we have 50 milliliters of sodium hydroxide added. So starting the problem over, just starting with 50 instead of 10 now. Same equation, water still doesn't matter. We have 5 millimoles of NaOH this time though. 10 millimoles from our 50 times 0.2 and 0. Reacting them, we have 0, 5, and 5 millimoles left. Divide by total volume, which is 100. So we have 0.05. And then our sodium nitrate, again, doesn't matter. So negative log of 0.05 gives us a pH of 1.3 now. So pH is increasing, just not very much each time. Okay, now we have 100 milliliters of sodium hydroxide. So go ahead and set up your table. We have sodium hydroxide plus our nitric acid yields sodium nitrate and water. We have 10 millimoles of each of them now. So it's going to be minus 10, plus 10. So we're left with 10 millimoles. Our total volume is 150, but if you look at what we're left with a neutral salt. So the concentration of that neutral salt doesn't really matter because it's not going to affect pH. The only thing I'm left with is something neutral and water, so my pH must be 7. And notice we're also at the equivalence point because we had equal amounts of acid and base. Okay, go ahead and set up your table for this one. And that should be sodium hydroxide plus nitric acid. We have 15 millimoles, still have 10 and 0. React it out, minus 10 plus 10. We have 5, 0, and 10. Divide by total volume, which is 200 milliliters. We have a strong base and a neutral salt. So again, the only thing that matters is our strong base. Our concentration of that base is 0.025. So because it's a strong base, my pOH is equal to negative log of 0.025, which is 1.6. My pH then is 12.4. Okay, finally 200 milliliters have been added. Go ahead and try this one on your own. Okay, you should have had 20 millimoles and 10 millimoles. $10 millimoles across, and then we have 10, 0, and 10. Divide by total volume, which is 250. Neutral salt doesn't matter. NaOH's concentration is 0.04. So pOH is the negative log of 0.04, which is 1.398, which is basically 1.4. So my pH is 12.6. You also need to be able to read titration graphs. So on this one, first, you need to figure out what's being titrated by what. If you look at our pH, we're starting at a pH around 1, which means it must be a strong acid. also, our equivalence point is 7, which is characteristic of strong acid. We're ending at 13, which means strong base. And you're always going to titrate it with something strong. So make sure you recognize equivalence of strong and strong's always 7. Also, you can notice that near the equivalence point, a small amount of NaOH added is going to have a huge effect on the pH. So when you get close to the equivalence point, you've got to do it dropwise or your pH will skyrocket. This one, you can tell we're starting at pH of 14. So we must have a strong base that's being titrated by a strong acid. Again, equivalence 0.7, and we're ending with a low pH.